Hello everyone, I welcome you to this video, and today I'm going to discuss the structure of an atom. And before we go further, I'll start by the definition of an atom so that we can know what we are dealing with. Now, an atom is the smallest particle of an element that can take part in a chemical reaction. So from the definition, we know that it is the smallest particle of an element. So from that definition, we can conclude that atoms make up elements. And if they're the ones that take part in a chemical reaction, it is atoms that gives elements their chemical properties. They define chemical properties of elements. Now, having known that, we really need to know the structure of an atom. Structure of an atom. Now, the first key thing we need to know as far as structure of an atom is concerned is that an atom consists of a nucleus containing protons and neutrons. Consists of a nucleus containing protons and neutrons. The next thing we need to know as far as structure of an atom is concerned, an atom has shells which contains electrons. Now, I'm going ahead now to draw and to give you a sketch of how an atom looks like so that we can be able to understand what we are dealing with. Now, we've said that an atom has a nucleus, I'm going to label this as the nucleus. This one is going to be my nucleus, and these ones are going to be my shells. When it is singular, we call it shell, and it is one. Now, I've said that an atom consists of nucleus containing protons and neutrons. Now, I'm going to draw protons and neutrons within the nucleus. I'm going to draw different circles. Let me use a different color. Now, I'm going to have protons and the other color is going to represent neutrons. Now, when dealing with protons, the first thing that we need to know, protons are positively charged. While neutrons are negative, have no charge. Sorry, they have neutrons have no charge. And we've said suspended within the shells are electrons. Now these ones are going to be our electrons. Electrons. So when I come down here under electrons, I'm going to say are found within the shell and they are negatively charged. They are negatively charged. So from this point, we've known what an atom is, its characteristics. We've said that protons have positive charge. So within the proton, within Inside the protons, I'm going to put a positive charge to show that they are positively charged. But neutrons have no charge. Electrons are negatively charged. So I can put a negative charge, and I'll explain further as we proceed with our discussion. Now that's how structure of an atom looks like. So there are key things that an atom constitute towards the arrangement of elements in the periodic table. Now, we have to know that an element can be arranged in the periodic table based on the number of electrons and protons they have. So most of the time, you can always find a periodic table of elements, and how the elements are arranged there can sometimes be tricky. But the key thing I want you to know is that the arrangement of elements on the periodic table constitute a lot of things that helps us to understand various things as far as certain elements are concerned in the periodic table. Now, the number of neutrons and the number of protons in a given atom constitutes the mass number of that given atom. So the key thing that we also have to know is that atoms can also have their masses. And for that matter, each atom has its own unique mass. And for us to get the mass of an atom, we have to know that to get the mass number of an atom, we call it mass number. Get the mass number of an atom, we get a summation, or we add the number of protons and neutrons within the nucleus. Within the nucleus. For example, you might go to the periodic table, and most of the time you may get worried about a certain given element in the periodic table. For example, I can have a drawing such as this, a sketch. I'm just doing a sketch so that we can understand what I'm dealing with here. I can have a sketch like this. It's always in form of a box. And this box, in the middle part, we have something written like this. I'm using lithium, for example. That's lithium. And either on the top or at the bottom, you may have, as fusion nearby, we have 3 written here, and at the top we have 7. Might have 3 or 7. I'm using lithium as an example here. And the key thing that we have to know is that most of the time, when you see things written like this, there are certain things you need to be knowing as far as this structure is concerned. Now, we can have this information given there. The Li, the Li, the Li represents the element's symbol. Symbol for lithium. Three represents the atomic number, of lithium, and in these mean that the number of protons found in the nucleus of lithium atom. And 7, I'm using 7 because 7 is always an average, but in most periodic table you might find 6.9. But now, because we are beginning to understand chemistry, this is still chemistry for O level, you can sometimes find periodic tables using 6.9 or 7. But in this video, I'm going to use 7 as an average. Now, 7 represents the mass number of lithium, the mass number of lithium. So this one is going to be the atomic number, then Li is the symbol, then this one is the mass number of lithium. That's just an example. So most of the time, periodic table consists of boxes, and each and every box, these boxes are arranged vertically and horizontally. Now, each box have an information about that given element it contains. So sometimes when you see these, the periodic table, don't get confused. But most of the time, the numbers can be interchanged. Sometimes the 3, for example, in lithium can be on the top and 7 at the bottom. So the key thing that you need to know as far as lithium is concerned, 3 is always the atomic number, and 7 or 6.9 is always the mass number. Now, to summarize our session, what did we say? How are we getting mass number? We are getting mass number when we added number of protons, 2 or plus, let me use plus number of neutrons. So for example, for me to have 7 as the mass number of lithium, it means that 7 was gotten when I added 3, which is the number of protons, plus x. So meaning from the mass number, I can use mass number and atomic number to get the number of protons of each and every given element in the periodic table based on the data that I have. So in a situation whereby I'm having this, so if I want to get the number of neutrons in the nucleus of lithium, I'm simply going to do the subtraction. So I'm going to say that 7 is equal to 3 plus x. Now, for that matter, x is going to be 7 minus 3. So from that matter, for that matter, I'm going to have 4, and 4 is now going to be number of neutrons found in the nucleus of lithium. So for that matter, I can have a situation whereby, so when I have 7 being equal to 3 plus x, the key thing that I wanted to understand as a good student of chemistry, that this one represents the mass number, this one atomic number, because we are dealing with the lithium here, for example. Then this one is going to be the neutron number, the neutron number. Now I wanted to try 2 or 3. Calculate the mass number of the following. Calculate the mass number of the following elements from the periodic table. From the periodic table. A. Sodium. B. Chlorine. And C. I'm going to have bromine. Do the 3 questions and write for me the answer you've gotten in the comment section below. Thank you very much and have a wonderful time.